welcome.
Good afternoon. Can you hear me?
Yes, we can hear you.
Okay.
Yes, thank you so much for joining us. You are going to be telling us a little bit about the work you've done with Anglo Platinum, and their hydrogen haul trucks initiative. And that's a little bit teasing for crowd here. Before I hand over the word to you, I'm just going to do a quick introduction about you so people know a little bit more about your backgrounds. I hope you are not surprised, but you are the most experienced of all our speakers in this conference. Amazing track record. Really, when we were preparing this conference, we were just totally blown away. And you already founded your company more than 30 years ago, RTS Africa Engineering. Quite impressive. So you've been working on this topic for a long time. And if I understand correctly, your specialty is the application of imported specialized engineering technology. So you will explain this, but you work with end users to help them and apply specialized technologies in their day-to-day activities, including hydrogen generation. And this is specifically what you will be telling us about in your project with Anglo American.
Indeed.
With all this being said, I'm done and I hand over the words to you. Thank you very much. And you can share your presentation by using the green share screen button at the bottom.
All right, I've done that, but I don't see it.
Yeah, there we go. It's coming now.
That looks good.
Yeah. Just open your presentation. Your presentation, yeah.
There we go.
Yes, and now you can just go
back. It's gone again.
No worries, just go back.
But it's got. There we go. Yeah.
There we go. And
okay.
Presentation mode. Yes, perfect. Thank you.
Excellent. So, can we get going?
Yes, please.
Thank you, John. Right, well, good afternoon, everybody. The presentation I want to do is just a little bit wider than only speaking about the Anglo project, but that is, of course, a very, very important and pivotal part of this. I just want to touch on something that's been cropping up quite a bit in the discussions with previous delegates. There's always this constant implication that to make green hydrogen work, we've got to somehow be cheaper and compete with fossil fuels. Undoubtedly, ultimately, it will be cheaper and will compete. But in the meantime, I think it's a rather moot question, because it's a bit like saying, you know, we're destroying the planet by using dangerous fuels and energies. But if it's too expensive to change, well, we just have to carry on destroying it. And it always seems to me a rather pointless argument. But that is beside the point of my presentation. And let's proceed. I seem to be at the end of it. I don't know how that happened. I'm sorry. Apologies.
Don't worry.
Okay.
There we go.
At present, Africa is a net importer of energy. And energy is imported in the form of fossil fuels of various kinds. And this is happening at enormous cost and damage to the environment. The question is, why? Why are we doing this when Africa has the resources to become a net exporter of energy? Africa has got vast open areas with strong solar radiation and also wind energy. These two maps, I'm sorry about the top of North Africa being cut off on this map, but I couldn't find another one. But this gives you some idea of the energy distribution in Africa. On the left, the solar energy, which is enormous, and the yellow, orange, and red areas all deliver better than 5 kilowatts per square meter, and the darker orange areas deliver better than 7 kilowatts per square meter. And that applies also to wind energy. And although it doesn't look so widely distributed, wind energy is in fact a very, very effective source of energy in Africa. But how can these initiatives be coordinated? Well, the African Hydrogen Partnership is going to be the pivotal organization in achieving that. It was formed at an inaugural meeting held in Addis Ababa in February 2020. There were over 40 delegates, and they represented private, public, and administrative bodies from Africa, Europe, and Asia. In fact, we were expecting a Chinese delegation, but this conference coincided with the outbreak of COVID in Wuhan, and so for obvious reasons, we missed the company of the Chinese delegation at that time. But how can these initiatives be coordinated by the AHP? Well, it would be the primary driver for the uptake of green energy for the African continent. Studies by the AHP have demonstrated that Africa can produce sufficient green hydrogen to satisfy all energy demands in Africa, plus a significant additional volume for export. And how practical is this in practice? Well, Morocco is already exporting green hydrogen to Europe through a pipeline. The Port of Rotterdam has a major hydrogen terminal, which is geared for the importation of green hydrogen in Europe. And Japan has indicated to us that she will buy all the green hydrogen that Africa can supply. The specific project that we touched on earlier, the conversion of 2 ore haulers at a very large platinum mine, about 2 hours north of Pretoria, electric vehicles powered by hydrogen fuel cells offer major benefits to the transport sector. These benefits include refueling times that are comparable to internal combustion engine vehicles, long ranges, plus space and weight efficiency. I have to interject a little comment here. People seem to be absolutely obsessed with battery vehicles at the moment, which do not meet any of these requirements. Sorry, I've gone too far. I'll go back. Sorry. And batteries take a long time to recharge, and also you ultimately end up with a box of unrecyclable, rather nasty chemicals. The future is definitely hydrogen. I felt I had to get that in. Anglo American is leading initiatives to promote the adoption of fuel cell electric vehicles, FCEVs, for commercial use, facilitating the creation of consortia to promote the development of hydrogen freight corridors in various parts of the world. And these include the UK, South Africa, and China. So we are involved at a mine north of Pretoria to convert 2 ore haulers to hydrogen power. This is a pilot project motivated by Anglo American. The power supply will be solar with a grid backup. Hydrogen generation will be by 2 null hydrogen alkaline electrolyzers. The bottom right, you can see a null hydrogen electrolyzer. That particular machine that you see there would produce around about 100 normal cubic meters per hour of hydrogen. This project will use 2 350 normal cubic meter per hour electrolyzers, producing a total of 700 normal cubic meters per hour. The scope of this project, well, this is an extract from an interview by Engineering News, our local technical paper, with the Senior Vice President of Business Development, David Bowe. David says that the long-term target is to convert the entire fleet of haul trucks at Mogalakwena mine to hydrogen, and also to introduce decarbonized hydrogen mobility at other Anglo-American mines. It's important to understand that just one of these trucks, when diesel powered, consumes over 900,000 liters of diesel fuel a year, which equates to enormous amounts of carbon emission. If you look at the total installed base of 28,000 mining trucks around the world, the emissions from these trucks is equivalent to the entire emissions from a country such as New Zealand or Finland. You should have got a picture of New Zealand there. If you decarbonize these 28,000 trucks that are in the hands of open pit mining companies around the world, you're roughly removing the impact of 150 million cars off the roads, says Bo. So that's fine. That is one mine, and at the moment this project is proceeding very well. We expect to be operating these trucks on green hydrogen by June this year. But in the meanwhile, the AHP has been carrying out feasibility studies, and they've identified 3 hubs to create what would amount to a hydrogen valley. And these extend from Rustenburg to Pretoria, down to Durban, including the city itself, and up to Richards Bay, and inland to Limpopo province, centered on the Mogalakwena mine. That gives you an idea of the scope of the hydrogen valley. A second initiative, which is a much longer term plan, but this has emerged from meetings and discussions within the African Hydrogen Partnership, is that we foresee the establishment of a hydrogen road all the way from southern to East Africa, where all road transport would operate on green hydrogen. Roads running from Cape Town to Pretoria, on with some links down to the coast, up to Harare, on up into places such as Nairobi, Mombasa, Addis Ababa, and a couple of links inland as well. But this is all very well, but whenever we talk about these things, and I think possibly our audience for this particular conference may not be suffering from this complex, but I've found whenever I speak about hydrogen, there is an elephant in the room. Everybody thinks hydrogen, it is extremely dangerous. They want to discuss Hiroshima and Nagasaki, and of course the dear old Hindenburg never fails to get its mention in these discussions. Of course, most people listening to these conversations here will understand that Hiroshima and Nagasaki were atomic bombs, and hydrogen is not going to explode atomically all that easily. The Hindenburg, sure, that was a simple, straightforward thermal fire, but it was definitely due to extremely incorrect and dangerous handling of hydrogen. Null hydrogen, or North Hydro electrolyzers as they were at the time, actually carried out a test where a hydrogen-powered car with cylinders of hydrogen at the back and a petrol car with a conventional petrol tank were, the tanks were breached and they were set on fire. In 60 seconds, the hydrogen flame had to be begun to subside while the gasoline fire intensified. Within 100 seconds, all of the hydrogen was spent and the car's interior was undamaged. The maximum temperature inside the back of the vehicle was 67 degrees Fahrenheit. The gasoline car continued to burn for several minutes and was completely destroyed. If we proposed adopting the present system of storing fossil fuels in vessels as a new idea in this day and age, in a light metal, or even in some cases plastic tank, with an explosive mixture of petrol diesel fumes above the liquid in the tank, under the back seat of the boot of your car, or the boot of your car, Would you approve this arrangement? I think not. We're used to it, and we're used to watching movies where cars crash and burst into flame and burn out. Well, of course, it doesn't happen every time cars crash, but it is a risk. However, with hydrogen, it offers far less risk of fire, and of course, it doesn't offer any chance of liquid fire. It is stored in the vehicle in a high-pressure vessel. It is very difficult to rupture this vessel. I would mention the vessels are typical pressure vessels. If you threw them down the stairs, they would survive without any grief, although they may do some damage to the stairs. If hydrogen does leak, it has a much lower density and disperses rapidly into the atmosphere. This is one cardinal rule that we need to watch, and I'm going to leave you with this thought. All hydrogen installations should provide ventilation, so that should hydrogen leak, it can disperse easily and harmlessly into the atmosphere. Thank you for your attention. In Africa, the future is definitely green hydrogen. Anybody have any questions? I'd be happy to answer them.
Thank you so much, Ian, for the presentation. And yes, I'm sure there will be some more questions flowing in. But I do have some questions for you already. How difficult or how easy is it to transform a traditional vehicle into a hydrogen enabled vehicle, specifically for this hauling trucks? Does it require a lot of modifications, or is it a relatively simple process?
No, there is a fair amount of modification. Obviously, the diesel engines are removed. A fuel cell is installed, which will convert the hydrogen to electricity. With conventional vehicles, they can have up to a motor on each wheel. And I think that is actually what is happening with the ore haulers, because they are huge machines, as you could probably see from those photographs. I mean, you can sort of sit in the hub of the wheel and be quite comfortable. So each wheel would have an electric motor, which would be driven by electricity from the fuel cell, which in turn would be getting energy from the hydrogen storage.
You mentioned quite a large number at some point in your presentation, 28,000 ore trucks around the globe.
Yep.
I imagine, but I want to ask the question, I imagine that they are all equal to this potential of transferring to the hydrogen option, or is there maybe some limitation for similar trucks who would be in different regions?
Basically, they're all diesel operated heavy vehicles, rather like that illustrated in the slide. So there may be one or two very rare examples of an unconvertible ore hauler, but I certainly have never heard of it.
So this is a promising niche market, definitely.
Indeed.
And then another question, mostly from a solar person. Very often when we are talking solar with mines, one of the arguments is, oh, but I need a lot of space and I'm limited on space, or for some security reasons, not allowed to install some ground-mounted structures. How much solar are we talking about for producing the hydrogen required to fuel 1 or 2 trucks? Is there a rule of thumb, just to get an idea about how much space we're talking about, how many megawatts we're talking about?
I don't have that number at hand, but it is quite practical. It is a fairly large area of solar panels that would be required, that is correct. But fortunately in Africa, one thing we have is a great deal of space. And obviously they're not going to be installed in areas that are ultimately going to be mined. but those areas exist all around mines, and especially open cast mines, and this does not present any kind of obstacle or problem. Space is not really an issue with this. I'm sorry, I can't answer in terms of actual numbers. I can get that answer if you're interested to follow up.
Oh, yeah, I'm sure. We do have many questions, so I'm just going through them, and maybe somebody has asked some version of it, but yes, definitely we will follow up on this, no problem. Just looking at some more questions that have flown in. With 32 years of experience in hydrogen, what challenges did you have, and what main challenges did you have, and how did you overcome them? It's a life achievement question, but I think it's an interesting question for somebody with such a long experience as you.
Well, it was one of those strange things. We weren't really looking for getting involved in hydrogen, but in the early 90s, what was then Norsk Hydro electrolyzers were looking for people to represent them in specifically South Africa, but as it turned out to be most of sub-Saharan Africa. And one of your previous panelists, Eric Dabb, actually eventually became our contact with what was by then Nel Hydrogen. But we were appointed as Southern African agents for Norsk Hydro. And we began to, first of all, service existing electrolyzers, and then, of course, to promote the technology all around Southern and East Africa. At that time, of course, the applications were all industrial. It was a relatively small market. We were looking at steel annealing and glass production, peripheral alcohol manufacture, various very specialized applications. The enormous market for hydrogen as an energy transfer medium had not been really seriously contemplated at that stage. We actually came on board about 1996.
Last question, if you don't mind, before we invite Fernando to join us and to tell us about his projects and the technology that his company is rolling out. Last question from Keith. It ties in a little bit to the first question I asked you about the complexity of things. Keith wonders, how does the hydrogen vehicle compare to an ICE vehicle, so internal combustion engine, as far as the complexity is concerned? How many components can break down over time and may need maintenance?
Okay, the first part of that question, could you repeat it?
How does a hydrogen-powered vehicle compare with an traditional diesel engine, in this case, in terms of complexity? And do you have a lot of maintenance to schedule if you are planning on switching to hydrogen? Or on the contrary, is it a relatively maintenance-free type of engine?
It will, in principle, be considerably less maintenance than any kind of internal combustion engine. Your hydrogen is obviously stored under pressure. It gets converted into electricity in a fuel cell. The fuel cell may need new electrodes 5-6 years time, which is, and also it's a very simple job to change them over. And for the rest, it's electric motors, which are among the most reliable and stable of mechanical electrical devices that we have. There's really nothing could go wrong with them except an occasional bearing, and that's going to take years and years. So the simple answer is a hydrogen-powered vehicle should be extremely reliable and require far less maintenance than our conventional internal combustion engines, which, if you think about it, are quite complicated.
Well, Again, I mean, we're also working on other electric mobility applications here at AFSIA, and indeed, when we are comparing with the engines, the ICE engines that we have known for many, many decades, one can ask himself the question, why have we made that choice? It seems to be a similar situation with hydrogen-powered vehicles. So hopefully this will open the way to a very interesting market for you and for many other players. And definitely, I'm sure there will be a lot of people following up with you after this conference. There was a few questions about, can we get Ian's slides? Yes, of course you will, as well as the recording. And so we will also share all your questions so that Ian, but also all the other analysts and presenters from the 2 days conference will be able to follow up with you directly if you have a specific question for them. So Ian, thanks again. Thanks for sharing about the work you do.